Okay, so this video is meant for my Concepts of Algebra 2 students. We do have a quiz coming up on Tuesday covering sections 8.4 and 8.6. So this is your quiz review all on logarithms. Alright, so first let's evaluate some logarithm expressions. So we have two problems here. So first one, let's do A. Woo! Not what I wanted. Let's do A. Log of 10,000. Well, whenever you're evaluating a log, and this is not the change of base, this is without the change of base, we're going to let this be x. And now we need to know that this log has no base. So what is the base? Well, remember, there's no base. That's base of 10. This x is the answer. It's the exponent. So to rewrite this would be 10 to the x power equals 10,000. And then we need to know what power of 10 gives you 10,000. Well, the 10s work. You take 10 and you raise it to the number of zeros you want. So if you want 4 zeros, it's 10 to the 4th power. So the answer to this log is, of course, 4. Because 10 to the 4th power gives you 10,000. Alright, B over here, I'll use orange. Log of 1/2, log base 1/2 of 64. And again, I'm going to write this with an x there. The 1/2 is the base. The x is the exponent. So I will take the base 1/2 raised to the x power to get 64. And I want x. Okay? Well, 64 is a power of 2. It's 2 to the 6th. But look at this 1/2 being in the bottom. So we have to think about what exponents move things from top to bottom. And that would be a negative exponent. A negative exponent makes the reciprocal happen. So remember that. Negative exponent means the reciprocal will happen. So if I want this 1/2 to become a 2, I need to make the exponent negative. So if 6 makes 64, right, 2 to the 6th, then the answer can be a negative 6. Alright, first two down. I only have five problems, so first two down. Okay, we are going to evaluate this log using the change of base formula. Okay, so to do that, you need to write this as a fraction. Log of something over log of something. And the only thing you need to remember is that the base, so this is the thing to remember, the base is on the bottom. So if you look at this log, the 5 is the base, so the 5 goes on the bottom. That means the 81/4 goes in the top. And when you do this, don't forget your parentheses, and we do log of 81 over 4 divided by log of 5. And log of 81 divided by 4 divided by the log of 5 is 1.869. So this is the answer. This is what the exponent is for 5. This is the evaluation. To check, we can plug the exponent into the base of 5. So 5 to the 1.869 power. And roughly, you do get 5 to the 1.869 power. You do get roughly 20.25. So we need to check to see what 81/4 is. And 81 over 4 is 20.25. So they're equal. So this is the correct exponent. That's the answer, 1.869. Change the base formula. Okay, we're going to solve this equation here. This is an exponential equation. We're going to solve it using, of course, logs. This is an exponential equation with one exponent. So this is an exponential equation with one exponent. When you have only one exponent, you're going to use a log to solve this. So first thing I will do up here is I will put a box around the base and the exponent. So what I must do is I must get that all alone. So I guess I'll rewrite it down here. 10 to the negative x plus 5 equals 8. And again, I'll put that box around the 10 and the negative x. This 5 must be gotten rid of. So let's subtract 5 on both sides. 10 to the negative x equals 3. And now I'm going to take the log for this problem. Because the base and the exponent are alone, the The log here would be base 10. So the base is 10. The exponent is the negative x. So when I rewrite this over here, this is going to be log base 10. Now log base 10, I don't have to put the 10. Log base 10 of 3 equals negative x. And now remember, get rid of the negative by dividing by negative 1. That negative does not affect the 3, it goes in front of the log. Negative log 3 equals x. And now we can just use our calculator. No change of base formula needed. Sometimes you must use a change of base. And the negative of log base 10 of 3 is negative 0.477. So remember, sometimes you have to use a change of base depending on what the base of your log is. Okay, this problem here is another exponential equation, but we're going to handle it a little differently because notice this exponential equation has 2 exponents. So this is where you must use the equal powers property. So we need to put, or equal bases, not equal powers, right? Equal bases, sorry. Equal bases. So we need to have this 2 and that 8 become the same number. So let me rewrite this problem down here. 2 to the 6x minus 1 equals 8 to the x plus 1. I believe that I can make this 8 become something with a 2 to some power. 2 to the 6 minus 1 power equals, 8 is 2 to the 3rd. Right? 2 cubed is 8. With that x plus 1 on the outside. And now this is a power of a power problem. Power of a power. I must multiply the 3 to both of those pieces of that exponent. So 2 to the 6x minus 1 equals 2 to the 3x plus 3. And now, with the bases the same, boom, boom, they're gone. 6x minus 1 equals 3x plus 3. I will subtract 3 from both sides. That'll give me 3x minus 1 equals 3 on the right side. I will add 1 to both sides. That'll give me 3x equals 4, and I will divide by 3 on each side. And 4/3 is good, or you can round, I don't care, to 1.33 something, 1.3, whatever. And that's the exponent I need to make these two sides of the equation equivalent. So remember, equal basis property, 2 exponents, find that common base. Alright, two more problems, I promise. We're going to solve this log equation. Log base 4 of 7x plus 11 equals 1. So what I will do is up here, I'm going to put a box around the log and everything in it the log. So the 7x plus 11, notice the parenthesis. And I'll notice there's nothing else over here with this problem. So I need to immediately write this using exponents. Remember, when you have an equation, a log equation, with only one log, you're going to use exponents to solve this. So in this equation, the 4 is the base, and the exponent is the answer, remember, so 1 is the exponent. So we are going to rewrite this as 4 to the first power equals 7x plus 11. And of course, 4 to the first power is just 4. And I must solve this for x. Subtract 11. Negative 7 equals 7x and divide by 7. X equals negative 1. And of course, again, it's simple to check. 4 to the first power is 4. So I need to plug in negative 1 here. 7 times negative 1 is negative 7. Negative 7 and 11 is 4. So it does work. Alright, it does work. Alright, last problem coming. Alright, last problem here. We're going to be using the half-life formula to do this. So that formula is A equals A sub 0 times 1/2 raised to the t over h. Remember, A is the amount left, A is the original amount, H sub 0 is the original amount, t is the time you're probably looking for, and h is the half-life. So what do I have? Let me just label my picture. The half-life is 5.27 years. So this is your h. How long does it take? So that means, what is t? For 50 grams, so that's A sub 0 to decay to 20 grams, and that's the amount left over A. So if I plug it in, A is 20 equals 50 times 1/2 to the t over 5.27 power. First thing, put a box around the base and the exponent. This is an exponential equation, so we will have to use, it's an exponential equation with one exponent, so we have to use log to solve this. Now, the first thing I will do is I will get rid of that 50 by dividing both sides by 50. And what you get there is 0.4. So you get 0.4 equals 1/2 t over 5.27, or 1/2 to the t over 5.27 power. And now we're going to use logs because the base and the exponent are all alone. The 1/2 is the base. This is the exponent. So over here I'll write the base, log base 1/2 of 0.4 equals t over 5.27. Now I will multiply both sides by 5.27 to get rid of it in the denominator. Remember that it does not combine with the 1/2 or the 0.4. It just goes right here. 5.27 log of 1/2, log base 1/2 of 0.4 equals t. And now how am I going to handle this right here? Well, I have to use the change of base formula. The 5.27 goes on the outside 5.27 times, and on the inside we do log of something over log of something. And you have to remember, with change of base, the base goes on the bottom. So 1/2 is on the bottom, 0.4 is on top. I would suggest you do the top first, or the log part first. So log of 0.4 divided by log of 1/2. And I get 1.32 something. I'm going to take that and times it by 5.27. And the answer I get, it rounds to about 7.0. So it's about 7 years. So it'll take about 7 years for this 50-gram sample to decay to 20 grams. All right. Change of base formula. So hopefully this helped. You bring it in on Tuesday for this quiz, and we have good results. All right, thanks for watching. We'll see you later.